lab of constant velocity motion, I chose to observe the monorail at Disney World on my vacation last weekend. And in the use of computer models, I used Newton's second law to assume that the F net was equal to 0. So my computer model ended up predicting the experimental motion fairly well. So for my video, I chose the origin based on the point chose the starting time based on when the monorail first began to come into frame, and I chose the origin point as the point of the monorail, which I thought was the point that I tracked throughout the process. I used this point because it is easy to find in the video, and even though it isn't the center of mass of one monorail car, which is the which was the object I wanted to focus on, the point was at a fixed distance and direction from the center of mass, so it would be acceptable and would give me comparable information. So I chose the axis to be the path along which the monorail was oriented, and then I used the calibration stick based on the height of the monorail, which I looked up to be 3.315 meters from top to bottom. And the time between frames was 1/30th of a second, and the total time of the clip was about 2.6 seconds, because I chose to end it right when the monorail was about to go out of the frame. Because the monorail was at a constant velocity the entire time, it didn't really matter which end time and start time I chose, so I just chose the whole time of the frame. So then when I modeled this motion, I took the mass to be 7,000 based on the mass of one monorail car is 7,000 kilograms, which I looked up, and I chose the initial velocity based on my initial position based on the tracker data, and then I found the velocity again based on the tracker data by taking the final position minus the initial position over the change in time, and then I chose the start time to be 0 just for simplicity, and then chose the change in time to be 1/30th of a second because that was the change in time on the video, so I thought it would be easier to compare the information. And the change in time is sufficiently smaller than the overall time of 2.6 seconds in that way. And then I set this end time to be, again, about the same as my video, which is exactly 78/30, because there's 78 frames at 1/30th second per frame. And then I used Newton's second law to find the F net. Because the velocity is constant, it's not changing, so this portion of Newton's second law has to be equal to 0. We know that the mass isn't 0 and that the change in time isn't 0, so therefore I concluded that the net force had to be equal to 0, so I set that as 0 in my code. So then when I ran the simulation, I found that the ball started at 0 and then moved to the right, which you can see up here, and when you can graph the motion, you can see that it just gets more positive as time goes on. So this is moving to the right at a constant velocity. And then I used this information from the computer model and plotted it against the experimental data. This red represents the motion on the model, and the blue is the data from the experiment. So it was a pretty good predictor of the experimental motion. It's just a little different here, and I think this is because of experimental error and in filming the monorail. I wasn't holding the camera totally steady, so the monorail was deviating from the axis a little bit, so I think this is why the experimental model data doesn't quite match the model data. So then for the what if, I thought about what would happen if the origin was someplace different. So to illustrate this, I went back to the same program, and I just changed the initial position to be at -10, 0, 0 instead of 0, 0, 0. And then when I ran this, it looks like the same motion, except the ball started from the left and then moved to the right. So on the graph you can see that the position was initially negative but became more positive as time went on. So the velocity didn't change. It was still a constant velocity and the ball was still moving to the right. The only difference was just that on the graph the y-intercept, or you can say the initial position, was different. So it started negative and then ended up positive. And for the what does it mean, I thought about the different forces that were acting on the monorail to make the net force equal to 0. So the force that's pushing the monorail is its force that it exerts to move forward. And then the forces acting against it are the air resistance from the air and the friction from the track that it's moving on. But we know that that the magnitude of these air resistance and friction forces, I just moved them down here so it would be easier to see, must be equal but opposite to the magnitude of the monorail. So the push forces canceled out by the pull forces, and the net force is equal to 0 because it's at a constant velocity.